right? Page 8. So you will have this in your classifying triangles, because later we'll do quadrilaterals. By angle, you've got acute, right, obtuse. By side length, you've got, what did I start with? Equilateral, it doesn't even matter. Equilateral, isosceles, and scalene. This is page 8. I don't know how much you need on your study sheet, guys, but what do we know about an equilateral triangle? All sides are equal? All three sides are the same, and all angles are the same? What do angles measure in particular? 180 altogether, but because they're all the same, they're 60, 60, 60, all right? Isosceles, you've got two angles that are the same and two angles that are the same. Scalene, all sides are different, all angles are different. Okay? All right, how about this one? What would you, if the province gave you this one, it's like, classify this triangle, show your work. It's isosceles? Yeah, I think it's a pretty good guess. I'm going to ask you to just always hold off just a little bit before you jump to a conclusion. This is what I mean by that. If this is 25 across this side, then this side being the same as that tells you that this will also be 25, correct? Which means that we can easily find the top angle there. So we go apex. Sometimes they call it the apex angle. I think one year they used that and students were like, hey, what? Right? 130. That's showing your work, right? So you put the 25 there. You now know that this is 130. Now I would go ahead and label this thing, classify it. You go over here, and by angle measure, you have one obtuse angle right there. So obtuse. And maybe for your notes, you just tell yourself it's because of the 130 that you call this one obtuse. And isosceles is because of the two sides that were the same. However, I want to put twists on it just in case you come across. What if they didn't have the markings, but just the 225s there? Could we have still concluded that this is an isosceles triangle? Yeah, because two angles that are the same guarantee us that the sides across from those two angles are going to be the same also. And obviously we would have been able to find a third angle. And so just by knowing angles, you would have also been able to conclude that. Okay, let's try this one here. It looks like an isosceles, right? Because of the markings. Just hold off a little bit. If these two sides are the same, what do we know about the angles across? They're going to be the same. We just don't know what it is right now. So how would you handle this situation? Take away the angle you know. You're left with 100, right? So we'll go 100 divided by 2. That's 50. And so now you know that this is 50 and this is 50. Just make sure it adds up to 180, right? If you add them all up. So how would we classify this in terms of angle? They're all less than 90, see? They're all less than 90, so this is acute. Because we've got 80, 50, 50. That's what I'm going to do. Okay. And because of side length, it's isosceles. I'm just going to say because of the markings, right, that kind of gave it away. The markings told us this is isosceles. Just like that. The next question, I don't really like that one. But I guess if it's drawn to scale, we would have a point there. But they're always going to tell you that it's not drawn to scale. So let's go to these two here. I don't like this one. Because it looks like an obtuse, but we don't know for sure. So can I just introduce something here? Most likely they will do this. I'm just gonna make up numbers. I hope this works. Let me first try it. If I go, and I go 764 minus 100. 16 plus 25 minus 49. Yeah. Okay. Let's call this divided by, let me just try one more thing. 8 times 9. Yeah, that works. So let's say this would be 4, this is 5, and that is 7. You call it what, let's go with inches. 4, 5, 7. What do we know right away in terms of side length? In terms of side length, this one is scalene, right? Scalene, they're all different. You've got 4, 5, and 7 inches. That's why we definitely could make this one. But I'm gonna just, I'm gonna argue with this one here, the angles. Do we know for sure this is obtuse right now? Ignore the diagram, just think of the sides. Do we know for sure? We don't. Can we figure out the largest angle here? If any of these angles is obtuse, it would be this one, correct? Across the longest side, there's no way around it. So let's go and investigate. Cosine of A is 5 squared plus 4 squared minus 7 squared. I'm going to tell you, we're going to stop there. Our investigation will be over after this. Because, do you remember what I told you about this? If this is positive, what do we know about the angle that will result? It's acute. If this is exactly equal to 0, what's this angle going to be? 90. If this is negative, we have an obtuse angle, correct? So let's do this. 25 plus 16 minus 49. You get negative 18. You know what? This is a little overkill. I've never seen them do this, where they actually make you calculate the angle. But it doesn't hurt. And if this bothers you, it's like, no, Mr. Erickson, I need to use the whole formula. You won't stop me. Sure, go for it. If that makes you feel better, you go for it, right? This in turn gives you negative 0.2. In turn, this gives you, if you use the inverse, this gives you, let me just try this, 101.54 degrees. To a certain degree, it doesn't hurt to review cosine law. But for this task, you could have stopped there because they never ask you to solve for an angle, right? But we know that it's obtuse. So now we can confidently say that this is an obtuse scalene triangle. Let's put tricky on top of this one. Tricky, right? It's not very often that you will have to worry about that. Usually they're very straightforward. You just have to figure out the angles based on what you're given. Okay, the last one. You're with me, right? This one. What do we know in terms of angle? It's right. Because of the 90, right? What do you know? What do we know in terms of the side lengths? Sorry, somebody said something? Yeah. This is 45? Okay, awesome, yes. Use the sum of triangle is equal to 180 to figure out that this is 45. Right, we went minus 90, minus 45. Hold it, so what does that mean if this is 45 and this is 45? It's isosceles. Isosceles. Right? That helps us figure out those two sides that are missing, like we know it. So 0 side lengths, no problem classifying. The problem is when you're given all 3 sides, we can't immediately know for sure in terms of angle whether it's going to be acute, obtuse, or right. So we have to do a little bit of digging when all 3 sides are given. Got it? Okay, that's what the AC is going to be about. So just close your. Oh wait, I need you to be able to sketch. There's so much you need to know and so little time. Go to 11. Go to page 11. If I asked you to sketch an acute scalene triangle, how would you make that work? You may use markings, you may use numbers. Just got to make sure you make your point. Acute means all angles less than 90. Scalene tells us all sides. This is a fancy notation in math where this stands for congruent. It's also the same as equal. You just cross that out. You say all sides are not the same. If you want rather write different, go for it. So I will just go and sketch it like this, and I kind of make it look like all sides are different. And I'm just going to focus in on the angles. So let's see here. If this is 60 and this is 40, what does that add up to already? We're at 100. How much more do we need? 80. Do you think this is enough? All angles are less than 90, right? And they're all different. Done. You're done. If you want to do this, just to show the audience, hey, all 3 sides are going to be different, you go for it. Okay. All angles are equal to 180. That's something that the province would. Like, if you don't make that equal to 180, you're in trouble, okay? You need to make sure all angles add up to 180 if you want to do that. What about obtuse isosceles? What I do is, I always think of a roof, and it's just a very wide roof. Again, it doesn't have to be perfect, right? And I'll just make these 2 sides the same, and I'll just make this one bigger than 90. So can you use 91, Mr. Yeah. Can you use 179? Technically, okay. So I'm just gonna use 100, to make it an easy number. You're done. What about these 2? Should I make these 2 the same? If you want to. What's left? 100 is taken, 80 is left. You split it equally. That would make this 40 and 40, right? So it's up to you how you want to do that. Right isosceles, how would you do that? Isosceles, I always think of a roof. I don't know about you. I always think of a roof. So you basically just draw your isosceles triangle, and I'll just make the 90 show up at the top of my roof. The top angle is 90. And there you have it. You have an isosceles, a right isosceles triangle. Obtuse scalene, I just think of this, a triangle, all three sides are different. I'll just make sure this one is bigger than 90. And then I just go ahead and just use different markings for all three sides. And there you have your obtuse scalene. Equilateral. Easy. You can do it like this. And I like the 60s in there. It's always acute. Acute isosceles, I just think of a roof that is a bit more, the slope is more pronounced, right? It's steeper. And what can we do? If this is 80, this is 50, and this is 50, that adds up to 180. Boom. That's your acute isosceles. I want to do one more on page 12 before this one right here. I find this one, how would you classify this triangle here? What are you thinking when you see that? You see straight angles here, this one? See that one? If this is 120 here, what is this? 60, right? Because you've got the 180 going on there along this straight line. Over here, you see the straight angle? If this is 150, then this must be 30, right? You've got the straight angle going on there as well. If this is 60 and this is 30, then this must be, this is 90 already, right? So that must be 90 as well. But it doesn't look like a 90. They will have a thing saying not drawn to scale. That's how they get away with that, okay? So it started here, and then we went here, and then we were able to figure out this. So this would be a right what? Scalene. Because all angles are different inside that triangle. That's just how it goes, guys. Okay. All right.